Okay, so we'll take a look at another question. This is from the 2023 HSC Standard 2 Maths paper. This is question 38. This is the final question in the paper. This is also the same as question 23 in the Advanced Maths paper, and the solutions will be the same for both. So we're told a random variable is normally distributed with a mean of 0 and a standard deviation of 1. The table gives probabilities that this random variable lies below z for some positive value of z. So this is a cumulative probability up to z. The weight of adult male koalas form a normal distribution with mean 10.4 kilograms, standard deviation 1.15 kilograms. In a group of 400 adult male koalas, how many would be expected to weigh more than 11.93 kilograms? Okay, so we are told that the mean weight is 10.40. We are told that the standard deviation on that weight is 1.15. So we need to find the z-score associated with a weight of 11.93 kilograms. So the way you calculate a z-score is mean, it's the score minus the mean divided by the standard deviation. Now we need the z-score in this case. Well, we actually don't know the z-score. We don't know this, but we do know the score has to be 11.93. So we know x has to be 11.93. Mu is the mean, which is 10.40. Standard deviation is 1.15. This will help us solve the z-score associated with a koala that has weight 11.93 kilograms. So we plug this all in. This gives us the z-score is 11.93 minus 10.40 divided by 1.15. So this gives us a z-score value. It's going to be 11.93 minus 10.4 over 1.15. My calculator tells me this is about 1.33, so it's 1.33043 ... This is about 1.33 if we round this to two decimal places. This is okay in this case because the next term following it is a 0, and then all of the other terms are relatively small. We also don't have more than 2 decimals in the table of probabilities, so z-score of 1.33 will be fine. So now we need to work out what percentage of koalas will be less than weight 11.93 kilograms, and that will correspond to the probability up to a z-score of 1.33. So the probability of under 11.93 kilograms is from the table probability where z is 1.33. So this is 0.9082. This is 90.82%. And so what this means is if a koala weighs 11.93 kilos, about 90.82% of koalas weigh less than that koala. And so there's about 8.18% that weigh more, just based on the distribution. So in a group of 400 adult male koalas, how many would be expected to weigh more than 11.93? Well, the probability that any one is less than that weight is 90.82. Therefore, the probability that any one koala is more than 11.93 is going to be about 0.0918, 9.18%. So we just need to multiply this probability, the probability that any given koala weighs more than the weight in question, by the number of koalas. So we have the probability is this, the probability of 400 that there will be koalas weighing more. Well, it's not a probability, this is the number. The number of koalas which have weight greater than 11.93 is therefore going to be equal to the number of koalas in the sample multiplied by the probability, 0.0918. So it's going to be about 10%. So the answer has to be a little under 40. So 400 times 0.0916. This comes out to be 30. From my calculations, this comes out. Oh, sorry, this is not a 6. This is an 8. This is 0918. Let me correct this. 8. On my calculator, this is 36.72. So 36 or 37 are two of the closest whole numbers. So these are the likely possible answers. If you are thinking about this in terms of probability, it could go either way, right? It depends how you think about the probability. It could round up to 37. You could say if you were optimistic about the number of koalas being above 11.93, you would round it up, right? So the people doing analytics where they are hoping for particular outcomes will often round things in their favor. So then you could round it to 37, and 37 is actually the closest number. But you could also argue that point anything of a koala is not a whole koala, so therefore it should round down, right? If you were being non-optimistic, if you were being quite stern about how the mathematics was working. So 36 or 37, and the marker notes are aware of this, right? The marker notes have their main answer as 36, but they will accept 37 as well, right? Either of these answers are possible depending how you do it and depending on your assumptions. So let's talk about the marking. So the marking for these questions is a little bit funny because you can do things in the order I've done them, or you can sort of structure this in a slightly different way. So you get 1 mark for finding a correct z-score or some equivalent. So if you're able to do a bit of working that gets you towards a z-score or get a correct z-score, that'll be 1 mark. You get a 2nd mark for finding a probability using the table. You get a 3rd mark for finding the correct proportion of the group of koalas. So this will essentially be finding the 0.0918 because we're after the number that are greater than, not the number that are less than. And then you get a final mark for the answer. So multiplying that probability by the 400 and then rounding that to either 36 or 37. So this is how we do question 38. And this question was present in the 2023 Standard 2 Math and 2023 Advanced Maths papers.